Welcome to another lecture on solar power generation system course. In this lecture, we are going to discuss about the type of solar charge controllers and the types of inverters which are used in PV systems. Okay, so starting with the solar charge controllers. Now, what are the solar charge controllers? They are actually present in between your PV module and your battery. This is your battery, and in them you have the solar charge controller. Now, solar charge controllers are of two types. And number one, we are also going to discuss how to choose the required type of charge controller for your battery. Okay, now let's say this is a PV module and this is positive and this is negative connected here, and then you have a battery which is charged by the same way. And this battery will be, obviously it can be of any volts, and it may have some ampere hour rating. Now, solar charge controller, there are basically two types of the solar charge controllers. The first type is the series charge controller, and the another type is known as the mppt controller, the maximum power point controller. Okay, so there are two types. Now, how to choose the rating of the solar charge controller? There are two things to look for. The number one is you have to identify its ampere rating, and number two is you have to look for the input voltage rating, and you have to look for the output voltage rating. Okay, now the input voltage rating, it may depends on the type of the charge controller it is. Normally they are rated from around 24 volts up to 380 volts, or maybe up to kilovolts, like up to 1 kilovolt or whatever the rating. So this is the input voltage rating. What does it mean? As I told you that if this is a PV module, there is a nameplate or the rating sheet behind attached, or it comes along with the PV array or the PV module. Let's say your PV module is mentioned that its the open circuit is around 22 volts. Then it means that the battery charger you should choose, it must be having the input voltage of 24 volts, okay, or higher, whatever it can be. But this is the general rule that how you decide its rating. Now, if you have more than one PV array modules, you have a type of a PV array. Okay, you have the series or parallel combination of PV modules. Then in that case, whatever the voltage of that PV array, your battery charger must be able to handle that voltage. So by this way, you have to decide the input voltage rating of this solar charge controller. And what about the output voltage rating? If the battery is rated at 12 volt, then it means that its output voltage rating will be 12 volt, and the charging voltage will be around 14.8 or 14.6 volts. That this will be the charging voltage. And if its output voltage rating is 48 volts, or 36 volts, then it means that you have to connect the 3 batteries in series. Okay, 12 volts battery in series, so that you will get 36 volts out of, so that you can charge those batteries. It entirely depends on its rating and whatever the battery bank combination you are going to have. Okay, so and what about the ampere rating? I just told you in my previous video lecture that how to find out the charging current or the current required by the battery. So your battery charger must be able to fulfill that amount of the current. And how, let's say, let me explain it again, but you have to look for the my previous video lecture in which I told you that how you can find out this current. Let's say the battery is rated at 220 volt, sorry, 220 ampere hour at 20 hours. So this battery will draw 22 ampere current. Okay, how I found out this 22 ampere current? You have to look for my previous video lecture. Okay, so in this way you decide the battery charger. Let me share my screen with you. I have some thing for you. Okay, now look. Is this recording or not? Let me show. Yes. Okay. Now look here. We have the first type, which is the series controller. Now, as I told you, the series controller, like here you have a charge controller and here you have a battery. These diodes are for the reverse current flow protection. And here you have two switches, the switch S1 and switch S2. What the charge controller is doing here is, let me turn on this. Now, what the charge controller is doing here, if the battery voltage is much less than the voltage which is to be supplied to the load, then it means that this battery has less charge in it, so it will disconnect the load. Or if the battery is fully charged, then this charge controller will disconnect this switch, that this battery will no more charge. Now this charge controller has also a built-in power converter, which is either the buck converter or a boost converter. Remember this thing, that this charge controller has a buck boost converter in it for sure. What it has a DC to DC converter in it as well. That is why it will maintain the regulated voltage across the battery. The another type is the maximum power point charge controller. Now this charge controller has, what is MPP charge controller? I told you in my previous video lecture. If you don't know what is maximum power point tracking or what is MPP based battery charging phenomena, then I will recommend that you should watch my previous video lecture, because in this video lecture I'm not going to explain what is MPP type of the charging. Now here you have this power converter, and this power converter, as I told you, what it does, it controls the battery charging current as well. Okay, and it has what? It has the buck boost converter in it. But here you may have two type of converters in it. Now, okay, so here you have another thing. This is the simple specifications of a charge controller. Here look, this is the specification sheet and this is the model. Here it is mentioned that the battery voltage 12 volt, and what is the maximum PV open circuit voltage? 26 volt. As I told you, what is mean by 26 volt and what is mean by 12 volt, and there you have the load current, the charge current, capacity of this charge controller. Now this battery charger, now look here, you have 25 ampere battery charger, 15 ampere battery charger, and now this battery charger is for the small batteries. Okay, if you have some high rated battery, then you will have to go for some different battery chargers which are rated at higher ratings. Here you have inverters. Now let me discuss with you the types of inverters with you. So there are basically three types of inverters which are available and which are commonly used along with PV systems. You have either the square wave inverters, you have the modified sine wave inverters. What an inverter does, it converts DC into AC, and then you have pure sine wave inverters. Now, square wave inverter produces the AC in the way that the alternating voltage or current is not exactly the sinusoidal. This is the AC output voltage from the square wave inverter. And the modified sine wave inverters provide you this type of voltages, this type of sine wave. And the pure sine wave converters, it has more precise steps that the sine wave looks exactly, that the waveform looks exactly like a sine wave, and it has reduced harmonics in the pure sine wave inverter. It is cheapest, and modified sine wave inverters are mostly used for domestic purposes, and pure sine wave inverters are required for medical equipments. Okay, so let me share with you again this PDF now. Look, this is the waveform of, this is the AC modified, and this is the modified sine wave power, and the pure sine wave and the square wave from the inverter. Now again, you have some specifications like this is the output power rating. You have surge rating. Whenever you turn on an inductive appliance, it draws somehow a larger current, transient current, so it supports up to the 1200 watt. So these are the ratings mentioned on all these inverters. Like here it is mentioned the output voltage, the frequency is another important thing, that the harmonic distortion, input voltage range, output voltage regulation, the protection. Then we have square wave inverters. Look, they are cheaper than you have. Okay, so here I'm going to end this video lecture, and we will meet in our module number 3. So till then, thanks.